Hello everyone, welcome to my co-instruction for the sequel paper written by Donald Chamberlain and Raymond Boyce at IBM Labs. Let's get right into it. SQL stands for Structured English Query Language. Now Dr. Chang will have talked about how SQL is used and the syntax of SQL. So let's talk a little bit about where SQL came from. What was the motivation behind actually making it, and the foundation from which it was created. So the direct foundation of SQL is actually a language called Square, which was also developed by Donald Chamberlain and Raymond Boyce. Same IBM Labs, and same guys and they started Square, and then they made SQL based off Square. So while this SQL paper talks about where SQL came from, I'm going to talk a little bit, and it also mentioned that it was based on Square, so I'm going to talk a little bit more of where Square came from and how it applies to the SQL that you read about. So Square stands for Specifying Queries as Relational Expressions. Apparently the guys at IBM liked nice, clean acronyms. Square was a progression from the predicate calculus, as you may remember from the relational database paper by Ted Codd. He defined a language that was based on the predicate calculus that could be used to query data from his newly defined relational database. The predicate calculus has some requirements. It requires users to define extra variables for everything. You can't implicitly say anything. You have to use extra variables. And they have to state every query using Boolean expressions and quantifiers. Predicate calculus-based languages were very difficult to anyone who was not strong in math, which was okay for Ted Codd because he was very strong in math. That's who he was. So why make Square? Why try and make something when predicate calculus worked already? Boyce said they wanted a language that was as complete as the predicate calculus, but easier to use by people who didn't have a PhD in math. He's quoted at the conference where he presented the Square paper saying, "We believe that the first order predicate calculus gives us a complete system, but one that is hard to use. What we have sought is to come up with a mathematically equivalent system, but one that's easier to use." So let's compare Square and the predicate calculus. Square, as you may have noticed, looks somewhat similar to SQL, but they didn't show you any predicate calculus in the SQL paper. So here's some of the differences. In predicate calculus, you need to select all the rows of a table, and then apply a predicate to it, and if true, return all the rows or a subset of the rows, and then iterate through the rows to find specific values you may want. Square tries the approach of looking at a table as a human would look at it. You would scan the column of a table looking for particular values, and if you find such a value that meets your requirements, greater than, less than, equal, or whatnot, it returns the elements of the column or columns that you were looking for. It's essentially taking a big table written on paper, scanning with your finger down the column the column you want to filter against, and then writing down the values once you find a row that works. So here's a basic relation. Every Square and every predicate calculus query, for that matter, has a range, a relation, a domain, and an argument. And the examples here I gave were find the names of employees in the toy department using the same relation that you read about in the SQL paper. So as you can see, you've got the name, which is the range, that's the value you want to get out, coming from the relation of employee. The domain is the department, and the argument on the domain is toy. You saw this exact query in the SQL paper when it was demonstrating the basics of Square. Now here's how you would do it in predicate calculus. Each of these B and R and A and S variables have to be predefined and mapped to name and employee and department and toy. And then it's just this complex predicate calculus, which I don't even understand. So as you can see, even by this simple example, square is so much easier to use than the predicate calculus, but still achieves the same basic idea of selecting something from a relation using a criteria. So what was the motivation for SQL? As was talked about, square was easier to use than the predicate calculus, but still not great. At the same conference where square was presented, a guy named Jack Minker spoke up and asked Boyce, wouldn't it be more natural to go to a natural language, such as just English, using an English query language, rather than a form that is less natural but similar to the predicate calculus? So while square was easier than the predicate calculus, it still required some background in math to be able to understand, so why not just use English words? Boyce's response to that was more of, it's impossible to parse the semantics of an English sentence to get exactly what you want. But it kind of got him thinking, and so the motivation of SQL was to have English words, but in a really predefined structure, hence the structured English query language. So now we will let Dr. Chang talk a little bit more about SQL, and hopefully that gives you a little bit better understanding of the motivation of going from predicate calculus to square all the way up to SQL and SQL as you know it today. Thanks.